What?
Oh, I'm trying to remember who did it. There was this skit that I saw where they were like, they were showing you the best way to handle a bully. And it was the bully was getting aggressive and put him up, we're gonna fight. Then the dude was just like, okay. And he's just like wiggling his hips, like shuffling over to the bully, and the bully's like,
What do I do?
what do you do? What did you do in there?
This is what I gotta deal with.
Oh, were we recording?
Oh yeah. It's staying.
I'm gonna unplug the camera.
Don't unplug it. It'll mess it all up. I'll save what I have recorded. No software is perfect, no matter how hard you try. No matter how much planning you put into the project, you're always going to have bugs.
Bugs exist.
We always hope we can write, like, you could do test-driven development, all these other things, and you're never going to run into bugs.
Good software engineering practices are like Clorox wipes. It'll kill 99.9% of the bugs, but there's still going to be some.
What we're talking about today is the process of identifying those bugs or those problems, and it's called debugging.
Yeah, it's the biggest thing is just how fast can you find them and how fast can you fix them? And debugging is a huge part of that. Debugging is not just about fixing the errors. It's having a systematic process to understand the behavior of code, identify discrepancies between what you expect and what the actual outcomes are, and then resolving them. So, I mean, the first thing is you have to have defined expected behavior. And that's where a lot of people go wrong when looking into bugs. And I mean, I get it from clients all the time. They'll say, hey, this is broken. Cool. How is it broken? Well, it's broken.
It's not working.
Okay, what do you expect it to do?
I expect it to work, Ben. That's what
shut up.
Yeah, so no matter how experienced a developer is, bugs are happening. Like, it can be silly things as simple as like typos, just misunderstanding of requirements. Like, I would say misunderstanding of like requirements is a very common.
That's usually where a lot,
especially in a disorganized startup.
Yeah,
like if you don't have like a product manager and like a product person and a design person, having those requirements like really tightly notched down.
And it's important to note that like there are different kinds of bugs, and those bugs come from different expectations. Yeah. There are the true bugs where it's, hey, this is just crashing the app. This is absolutely not working. There's something major going on here. And then there's bugs of miscommunication that are based in miscommunication, where it's the client said, we wanted this feature done in this way, but we didn't have enough details, or we didn't look into it enough, or we didn't validate early enough and say, hey, just to make sure this is what you want.
Yeah, exactly.
And they'll go, well, this behavior is buggy because it's exhibiting this behavior. And we're like, okay, well, that's how we built it.
Yeah, it's supposed to.
It's supposed to do that. Is that not what you want?
Yeah.
And they'll still label it as bugs. Mm-hmm. And I mean, even I have clients right now that we're having issues with some image taking stuff in the app that I inherited from them. And it's the image taking is buggy. Okay, why? Because I want it to function this way and have this user experience, but it does this thing. And I'm like, well, that's not a bug. That's how it's designed. Yeah. But if you want different behavior, then, we can have that conversation. But a lot of bugs typically just stem from the miscommunication, not understanding requirements, that kind of stuff.
And then the real fun ones are like when a dependency isn't acting the way that you expect it to, or something that's a little more out of your control, or even just hardware issues. Because bugs can happen anywhere, not even in your code. And when it's not your code, it's a lot harder to fix. Sometimes you can't.
Yes. And there's a lot that goes into debugging, finding these bugs and fixing them, whatever the source may be. And some of those things include having complex systems, like you mentioned, third-party dependencies. Modern software involves a lot of layers of different things, dependencies, systems, languages, frameworks. And from front end to back-end communications, APIs, there's tons there. And an issue in one layer can manifest itself into layers down the road. Like there might be on the front end, hey, this data is not coming back correctly. And at first glance, it might be, oh, there's an issue in the front end. Okay, cool. But it ends up being there's some error somewhere in the database on the back end, and that's being thrown and it's moving its way all the way to the front end, or, vice versa, bad data coming from the front end that's not being guarded against in the back end. So debugging can be complicated because you got to find where it is, and you've got multiple layers you might have to sift through, especially if you don't have systems in place to help with the debugging, which we'll talk about in a little bit. So there are those. There are non-deterministic bugs, which those don't occur consistently.
Those are the worst.
I hate
the ones that are super hard to reproduce.
Yeah,
are the worst bugs.
It's
especially if they are only affecting some users.
That again, same client. There is one user, one customer that they have that always has problems. Always. Mm-hmm. And I can never reproduce the problems. We've even gone to him, taken his device, and I can't reproduce them using his device.
Damn.
But he'll send me videos of it's doing this thing, and I'm just like, for the life of me, I spent a week and a half trying to fix a bug that, according to logs, according to everything, only this person has. And it drives me nuts.
Yeah, those are the worst. Those are the hardest ones. If you can't have reproducible, if you can't have reproducible steps, it's near impossible to track down and fix.
Yeah, which is why it's always helpful to have more information.
Yeah,
but again, we'll talk about that.
Interactions too. So especially in web development, you have so many different browsers and devices and all these other weird things and dependencies that can lead to crazy bugs. Web development is one of the hardest things ever because you have Safari, Chrome,
The
Brave,
next time you want to get mad at your web developer,
Firefox.
Go to a site called Can I Use It? And just go start looking at simple things of, does this feature, what browsers and versions of those browsers does this feature work on? And they have nice little charts.
Yeah.
And it'll be, for Firefox, it works 4 versions ago. For Safari, it works 1 version ago. For Chrome, it works 6 versions ago. And it's Opera and every browser you can think of is on there. And it's a mess.
It's a huge mess. Yeah. So you're depending on all these other platforms or apps essentially to work the way you need them to work, so your app isn't buggy. Mm-hmm. And that was our gripe with PWAs, right? Safari and Apple have way too many limitations.
Yeah, and there were so many features that didn't work on Safari yet and weren't accepted on Safari. And even things like playing video, getting the thumbnail to work. We had to do hacky stuff to get the thumbnail to show.
Only in Safari.
But only in Safari.
Yeah. And so you kind of started touching on this. Another complicated scenario for bugs is legacy code. Mm-hmm. Because one, you don't know if it was actually made to work that way or if it's a bug and not responding the way it's expected.
Yeah.
And then so when it's legacy code, not only do you have to track it down, you have to determine whether it is the behavior that's expected from the code or if something isn't working.
Well, and depending on your familiarity with the legacy code, if this is a project that I just inherited and there's a bug, I have to look into why is it doing it this way? Is this important? If I change this, am I going to break anything? Mm-hmm. Because a lot of legacy code bases just don't have unit tests and don't have the things that they should.
They could be poorly documented too.
Yep.
So honestly, anything that isn't unit tested, in my opinion, is poorly documented.
Yes.
Because a test should tell you what is expected from from your functions.
I would agree with that.
Yeah.
But it can be really hard with legacy code to figure out where is the bug? What is the bug? Is this intended? If I mess with this, is it going to mess with other stuff?
And then you run into comments like,
And then-
only God and I know.
Yeah, exactly.
What this code does. And now it's only God.
Yeah.
That is not a comment you want to see in code base you inherit.
No, absolutely not. It's the blood on the walls for developers.
All right. So yeah, bugs can be difficult, especially for like junior developers, mid-level developers, because it is not necessarily fixing bugs as an acquired skill, but the ability to track things down is definitely a learned skill.
Yes.
You get very good at tracking.
Well, and it depends on your ecosystem too.
That's true.
Because, for example, with iOS development and Swift, you've got Xcode and it's tightly integrated to just be Swift and Objective-C.
Mm-hmm.
And it has all these analytics tools for iOS and finding these bugs and finding performance issues. Cool. That's great. Enter web development, where some browsers have some of these tools that kind of help you. But depending on where you're at in the pipeline and where you're looking at it, if you're in a production environment, the code is minified and scrambled and all that stuff. And so clicking on, hey, there was an error here, let me click on it, gives you an unreadable string of garbage that you have no idea what it's doing, and it doesn't correlate to anything in the code base. And so that's harder to debug. And if you try to go into your IDE and use like breakpoints, a lot of times they just don't work.
Mm-hmm.
And so depending on your ecosystem, and what language you're using, what framework, all of that stuff, the skills that you need to debug in that environment change drastically, which is one of the reasons why junior level and mid-level developers tend to struggle a little bit more and take a little bit longer to debug things, is because they don't have enough experience in that ecosystem to know how to use the tools effectively.
I agree. And I would say like one of the positive things with like Xcode is it is quite amazing with their debugging tools and like being able to see memory leaks and like all of that stuff. They do a really good job on giving you tools that make your job a little easier.
Yeah, absolutely.
Like the more you get into web development, I feel like the more like it's kind of Wild West.
It absolutely is. And it drives me insane.
And that explain, like, honestly, like that's JavaScript.
I cannot tell you how many times it's been 3:30 in the morning and I'm staring at my screen just going, I miss breakpoints.
Yeah, no, for real. And not only can like bugs be annoying and make parts of your app break, it can be costly bugs. It can prevent maybe like purchases from happening, or just a blow to your reputation.
It's really important to have those debugging skills there for efficiency, for quality of the fixes, because depending on your debugging skills and your ability to truly diagnose a problem, it's not uncommon for developers to say, oh, okay, I fixed it. But what they fixed was a symptom of the bug, and it was the symptom that people were catching, and there's a deeper underlying issue that needs to be fixed. And so they say, I fixed it, and then 3 weeks later, it's manifesting itself again, either in that exact spot in the same way or in different ways, and it's, oh crap, it's not fixed after all.
Yeah, you get that good regression effect.
Mm-hmm.
Where like it comes back or you break more things.
Yeah.
And it takes you a few weeks to find the more things.
and nobody likes that. The business doesn't like that. The customers don't like that. And the developer goes into a spiral of shame and despair and reconsidering their career. And
for sure.
Not that I have any personal experience with this at all. But anyways, quality is important.
Very important, right?
Like you said, it can be really costly. And it takes a while to learn the skills to properly debug, but it does deepen your understanding of the code base that you're working in and code in general.
Systems and stack too.
Yeah.
So like everything, like it is a lifelong skill. I don't think you'll ever meet a developer that like will brag about how amazing they are at like debugging.
Yeah.
Because I think it's a constant learning curve.
Yeah. I mean, I don't think you're having enough faith. I'm sure we could find a developer who brags about their.
That's true. Well, I mean, I'm pretty good at tracking things down, but it's more.
See, done. I found one.
But I will admit, I'm not good at using like typical like logging tools and things.
Yeah.
I'm kind of good at just like knowing where it's coming from and finding it. You know?
Yeah.
I don't know. Everyone does it differently, and everyone like builds their skill set over time. Elixir, I'm good at tracking down bugs.
Mm-hmm.
Swift, I'm really good at tracking down bugs and fixes. JavaScript, I would probably struggle and be a little slower at. It's just because you're not in that ecosystem all the time.
That's because JavaScript doesn't even know how to use JavaScript.
It's the Wild West.
There are so many videos on top 5 WTFs with JavaScript.
Yeah, definitely.
And it's like null does not equal null. So yeah, it's an important skill. It's something that your developers or you as a developer are going to be working on your entire career. It never goes away. You're never going to have bug-free code. You're always going to be solving bugs.
Yes.
But the biggest things that you got to learn, there are a lot of tools that you can use outside of here's my debugging environment to help you build that skill.
So the first one though is mindset.
Yeah.
Because developers suck at keeping it together.
It's true.
They get in their head.
I mean, maybe it's we have way too much caffeine, maybe we're exhausted or whatever. But when you run into a bug, at least for me, the initial response is panic.
Yeah.
And I'm just like, oh, crap. Where's this bug? I got to find this now. And
then push it live without doing true tests.
Exactly. Because we got to fix it now.
Yeah.
So you catastrophize.
Yeah.
And you say, this is the end of the world. And, you have, and it's hard not to.
Right.
Because typically outside of, in a healthy environment, this isn't the case. But in a lot of environments I've been in the past, it comes in the form of, here's an email where the title is in all caps. App is broken, 3 exclamation marks. And people are in your ear and getting upset at you and they want it fixed now. And so that sense of urgency pushes you into a panic and I got to get this done now. I got to get done now. But that's the worst thing that you can do.
Right. There are moments for panic, but assess what the bug is first. Like if it doesn't include like monetization and the complete like if your app's fully not usable, it's probably not the end of the world. Yeah.
You want to stay calm and you want to look for a few things. It's really just taking a logical approach and taking it step by step. So the first thing that you want to look for is reproducibility.
Yeah, you want to ensure the bug can be consistently reproduced. Like we kind of touched on this at the very beginning. If you can't, it's one of the hardest things to track down. And it'd probably actually be a waste of time to assign a developer unless you have free time for your developers. You don't want to just send them on a wild goose chase. You want to have the reproducible steps so they can actually go about it in a logical manner.
Yeah, well, and it helps to diagnose things and build out your ideas on what is it and how can I fix it if you can reproduce it.
Correct. Yeah.
Because you have steps of here's how you make this happen, but you also have a list of this doesn't affect it.
Mm-hmm.
And so from that, it's kind of like when a doctor is trying to diagnose a disease, they need to know all of your symptoms. They need to look for anything that might be interconnected. They do tests for, hey, do they react to this? Do they not react to this? And that way they can build a hypothesis and they can hypothesize and say, hey, this is a list of possibilities and this is what I've ruled out because of these reasons.
Exactly. And then once you have that list, you can break down your problem into just manageable, smaller parts.
Yep.
And you just have to divide and conquer.
And
the important thing is do it logically.
Yeah, you just kind of rinse and repeat that process of, hey, I've broken down my list. Here's the possibilities. Here's what I've ruled out and why. And it is important. I like to write down as I'm debugging things. I'll usually go into like my ClickUp ticket and I'll say, this is what I've ruled out for these reasons.
Yeah.
Because if at any point something changes and it's, hey, the user told me this didn't change anything, turns out it actually was, they just didn't notice it, then that's back on the table.
Right. And like what's important is like when you have it broken down into like manageable parts, it allows you to logically step through things instead of like letting your mind jump you all over the place trying to track down this bug.
Yeah. And so you just whittle your list down until you've come to the conclusion of this is the problem, this is why. And now I can look at how to truly fix this.
Exactly. We've talked on a very like macro scale. What are like some techniques that you would initially start when you start tracking down shit?
Well, for web developers, we love ourselves some print-based debugging. And honestly, this is not a great way to do this. The only reason that I end up doing it this way a lot with web development stuff is because options are pretty limited.
Yeah.
But print-based debugging is where you use print statements like console.log, or in other languages, they're like print and printf and all that stuff, where you just put whatever data you need onto the screen.
Onto your console, yeah.
And I'll have like 6 different lines of line 1, testing 2, testing 3, testing 4 to see, okay, where does it break? Which statements are showing up? And if I print out data with that, which ones have the correct data? And at what point does it get screwed up and not give me the results I'm expecting? Because then I can go back and say, okay, well, in line 433, right before this print statement, it is fine. And then immediately after this print statement, it's not fine. So it's got to be this line. So that's just stepping through, printing out data. Absolutely not the best way to do it, but sometimes your hands are tied and it's hard to do it any other way. Another good debugging technique is automated testing, which we've talked about at length. And that's just in the past, that is, which is just using unit tests to pinpoint where the error is occurring, because it's really nice to be able to just run a suite of tests and say, hey, this crap over here is broken. Let me run the tests and, oh, there's a red X over here. So clearly something's broken in this function. I'll go look there.
And then there's like static code analysis tools that you can use. And I'm not going to like go into it because there are hundreds of them.
Oh, yeah.
So, but what it does is it will analyze your code without actually like executing it and help you find potential issues with it, which actually like a lot of people will, with the hype of AI, are using AI to solve or debug snippets of code.
Look, if I wanted an AI system to steal my code,
yeah,
that's what's crazy to me. Not to go off on a super tangent, but all of these people are so willing
to just
give them their proprietary
guys, everything you input, it's theirs now,
right? Like it's just crazy to me that they're so willing to be like, hey, I want to use AI to analyze our code base and save me 20 minutes.
Yeah. Well, I haven't done this, but I have seen like people talk about using it for like trying to optimize code, which is wild to me, but maybe it works.
I don't know. Different discussion. I just think it's crazy.
It is a little crazy. But apparently if you just have your code in GitHub, they're stealing it anyways.
That's
thanks, Microsoft.
That's true. So yeah, you've got static code analysis. There's also pair debugging. It's kind of the same thing as pair programming, which we've talked about before. It's where Jacob and I decide who's going to be Big Spoon and Little Spoon, and we debug together. But
yeah, but like honestly, just pair programming, it does help. And it's like kind of the same concept. So like if you don't have someone to pair program with, they do the rubber duck debugging. And this is like, you'll see all these dorks with rubber ducks on their desk.
Yeah, dorks.
This is what it is. But it's basically just explaining your problem out loud to yourself. It allows you to gain clarity, and like sometimes just speaking your problem makes you understand your problem.
Well, yeah. I mean, it's the same. It gets a lot of crap and people go, oh, nerds. I don't have rubber ducks. I do have other things that I talk to in my office to do the same thing, but they're not rubber ducks.
I talk to my dog. It's a little more normal.
Look, if he can teach his dog Elixir, he can teach you. But
he is actually quite a good developer.
But it's just that idea of verbalizing it, and you end up stating what your problem is and reworking it.
Yeah.
Just like, I mean, we were having a conversation before we started recording this episode of, hey, how do I solve this problem with my content? And just you reframing it and going through, well, this is my problem. Oh, wait.
Right.
And it was easy to detect, hey, here's an easier way. I'm overcomplicating this.
Yeah.
And that's what that is about. It's about taking a step back, working through your problem again in a calmer manner.
For sure.
Because most people aren't screaming at the rubber duck.
Ah!
The app is on fire, ducky!
That's what you're just smashing your desk for before you start talking to your rubber ducky.
Release time is so much fun. But you're just explaining it calmly and reframing it, and it helps you refocus your efforts.
Yes.
And look at other options.
Yeah.
So it sounds stupid,
but it's quite helpful.
but it is really helpful.
Like I do it without, I didn't actually know it was called rubber duck debugging, but you do it without realizing you're doing it.
Yeah.
As just a natural problem solving technique.
And it's like, I've been working on this for an hour and a half. I'm frustrated. And I sit back and I go, okay.
I'll sometimes even write down the process, like just hand writing versus typing helps you like visualize.
Yeah. Yeah. So that's what that's all about. And it is actually more effective than people like to admit.
Yeah. Sorry for calling you guys dorks.
It's okay.
And
I forgive you.
Like there's also like integrated debugging tools we touched on, like Xcode, just having tons.
Yeah, like breakpoints. And now I'm realizing people might not understand what breakpoints are. They're just, you can go into your
it pauses
development environment
where you want it to,
and you put a little button on it, and it stops when it gets there.
And you can like inspect variables and objects and see what data is on that line of code.
Yep, it just freezes your program, and you can look at the internals and see what's going on, what the data is, where things are, what processes are running.
And like very similar to breakpoints, you can also like step through executions, which is like basically it pretends a break line. A breakpoint is at every line. And so you can step through your code line by line, checking to make sure everything's happening that is expected. And that kind of will help you narrow it down. Like, cause like you could hit a line that calls a separate function. And then when you get past it, that's the bug. And so now you know you should probably dive into the function being called above. Yep. So it kind of helps you just step through your code base instead of just looking at a whole chunk of code without any like plan of attack. Right?
Yeah, exactly.
So yeah, you watch your variables and you can monitor specific changes.
Yep. And then you have call stacks, which they're really just, it is what it sounds like. It's a stack of calls, and you can go down into those, checking out methods, functions that are going on, and seeing which underlying function is causing an error. Like if I've got a list of functions that this function is running, I can step into those and go see, okay, well, it's calling this function over here. Let's see what happens after that or inside of that. And you go step by step down the stack. Another good one is error logs, which we encourage everybody to have in their apps. Some people like to argue that it slows down your app, and technically, yeah, a little bit, but logging everything can be indispensable for debugging things and finding problems. For sure.
Like, yeah, digging into logs, not my favorite thing to do, but you're really grateful that you have them when you need them.
Yeah, it's most of the time you don't need them, but when you need them, you need them.
Yeah, exactly.
Those are all good integrated tools that can be used for debugging. And you just got to figure out how that all works in whatever language, framework, development environment you're working in, and make sure that you're using it efficiently. And if you're sticking to, hey, I'm strictly a JavaScript developer, figure it all out for JavaScript, find an IDE that allows you to do those things that you like and stick to that. If you're doing Elixir, same thing for Elixir, whatever you're doing.
Exactly.
So those are all good tools. Some external tools that are also helpful are things like version control. Version control can actually help you a lot with debugging things, because you can see a history of, hey, in the last release of our app,
we didn't have this
bug.
And now we do. And now you can compare those code bases.
Yep.
Or versions, I should say.
You can compare what's going on between the files, see if there's an issue. You can do side-by-side comparisons. There's even tools inside of Git called Git blame, where you can say, hey, this issue over here is this commit's fault, this file's fault.
Yeah.
This is what happened. And you can flag things for that.
Yeah, which is super beneficial. I feel like people underestimate the power of using like Git.
Mm-hmm.
Like they think it's just, PRs and making sure you're not putting bad code in, but it's also gives you
exactly
history.
I mean, I like to save using Git blame, for example, for shaming people. Like I don't use it for bugs. I just like to point out crappy code. And
Ben likes to shame people. And then once you have bugs, it's really important to use systems to keep track of them. And so Jira is a big tool for that, which is also just like agile methodology and just project management in general. And then Bugzilla, we like to use ClickUp, but you can also even use Git issues, like GitHub issues.
Yeah, and I'm trying to remember the name of it. There was, what was the name? There's some library that you can implement in iOS and Android where the users can actually shake their phone.
Oh, yeah.
And it automatically reports. It gives a report of what happened in the last 5 seconds.
Yeah.
And they can report a bug.
Yeah. I think it's just what is that library called? It's been so many years since I've done iOS.
Yeah,
development.
I'm blanking it. I just remembered it.
But yeah, things like that are super beneficial too. And the shaking is a lot of people don't know it. So it's kind of saved for your QA team, but it allows them to easily report things, even if they're at a concert with their friends, right? And they're using your app and then something happens, they can
and you can always guide your users and say, hey, have a little question mark thing going on and give a tutorial of this is how you report an issue.
Yep.
And you just tell them, shake your phone. Oh, hey, look, that's cool. And they can walk through
so
it.
now with that, you establish an awesome system for reporting bugs, so you're not just shuffling through your customer your customer email, whatever.
Yeah. And I mean, right now,
customer support. Why could I not think of that?
With a client that I have, the logging isn't there. It's an older code base. It isn't there.
Mm-hmm.
And I'd like to change that soon. But what they have to do right now is this user emailed us and said, we're having a bug.
Mm-hmm.
So now every time I make a change and I'm testing something, they have to go back to that user and say, hey, install this version and see if that fixes it. And let's dive into your data and see what might be going on here. And they even go as far, before I started taking care of things, they went as far as, what's your username and password so I can log in and see what's going on? And it's just this is insane.
Yeah. Yeah. And then along the lines of debugging, being a part of online communities is super important. There are lots of Slack communities. There are Discord servers, and you kind of want to join. I'm involved in Elixir. Mm-hmm. I like to be in Elixir specific communities because if I run into weird bugs and I don't know how to figure it out, I have a whole group of people I can bounce ideas off of.
All 3 of them. Just kidding.
I'm not my community. There are Elixir.
No, that's
channels,
what I'm saying. Is other Elixir channels, all 3 of them.
Hey, it's growing, man. But also with Elixir Mentor, I have my own Discord server. We're not just helping each other on my YouTube content. We can help each other for everything.
Yeah, and that's super important.
It's nice to have that community of help. And there are things like Stack Overflow, and Stack Overflow can help you, but you have to sift through a lot of shit.
There's a lot of noise.
Yeah.
So
if you don't have good bad code smell, Stack Overflow is probably not a good spot to start.
It's dangerous.
Yeah.
There's all kinds of stuff in there where this is not recommended at all. The setting your ports to asterisk.
Yeah. Ooh, how do you fix this Coors error?
I saw that in Stack Overflow,
and
it was the accepted answer and had the most upvotes. And I was like, no.
Yeah, people are upvoting it. That's the problem. And even Reddit has its good resources.
Mm-hmm. Yeah.
Just get ready to be called a moron.
It's okay.
And so there are also good preventative measures to set for avoiding bugs.
Oh yeah, absolutely. Code reviews are indispensable for that. It's having somebody else go through, look at your code, see, hey, what's going on here, and having that second set of eyes can give you different perspectives on how to solve a problem if yours isn't optimal. Like because there are a lot of times where I look at things and I'm like, I don't like this solution, but I don't see another way to do it.
Yeah, and that happens so often.
Yeah.
Like, we all do it. And then just one other person's perspective is like a new
and it
world.
gives you ideas.
Your eyes are wide open.
If there are small errors in there, like typos and that kind of stuff, they can catch it a lot easier because they're looking at it fresh. They haven't been staring at this function for 15 hours. And so code reviews can really help prevent bugs. And it's insane to me when companies don't utilize them.
Oh, it's so dangerous, in my opinion. And then we touched on this in a previous episode, but like continuous integration is huge because you're automatically running your tests, and it's just running more checks.
The best tests are the one that sit there and gather dust because nobody ever runs them.
Because no one runs them. Well, we don't like to run them because they fail.
Maybe that's a problem.
That could be a problem, my man. Like, I like Elixir because it's based solely on keeping good documentation.
Oh yeah, documentation is really important, and keeping it updated is even more important. That's one of the reasons I like Rust too.
Yeah.
Is it's got that system in there. You can auto-generate your documentation. Elixir does the same thing, but it just makes it easy to manage because no developer likes managing docs.
What's cool with Elixir is you can run examples. So you can have your documentation above your functions or modules, whatever you want to do. And then you can have examples of how that function works.
Yeah.
And they're actually ran in your tests.
Oh, that
so
is
you have,
nice.
Yeah, it's so cool. So not only do you have your like unit tests that get ran, you also have your document tests that get ran. And I think that's really sweet. So documentation, and then keeping your software and libraries up to date, especially like for security vulnerabilities.
Oh yeah.
And all those other things that, like, if you're ever having a bug with a dependency, you probably want to make sure you're on the most recent version of it before you waste time trying to fix it.
And if you are on the most recent version, you want to go check, like, get issues and that kind of stuff.
Because there could be a new issue.
Because there could be a new issue, and the fix is revert.
Go back to the previous version until it gets fixed. And those are the best bugs because they're the easiest to fix and they're not your responsibility.
Yay! Finally one that's not my fault.
Unless you were the contributor to the open source project.
Damn it. So we've talked a lot about preventing them, what to do with debugging. There are a lot of common pitfalls with debugging that people fall into as well. And these are things that you just need to look out for and kind of avoid. For example, tunnel vision is a big one. You get fixated, like I said earlier, you've got clients in your ear or customers in your ear going, hey, your boss is at your desk or emailing you or slacking you or whatever your situation is. And this needs to be fixed right now. You get pressured, you get anxious, you get hyper focused on it. And that's where the tunnel vision comes in, because you find one potential cause, you're in a rush to fix it. And so you're diving deep into that cause, and a lot of the times you're just focused on the symptom and you're not looking at the whole picture. And you can even find things that this isn't the issue, but you're trying to make it the issue because I've been trying to fix this bug for 5 hours and
you
I've
don't
got
know
nothing else.
Yeah, you don't know what else it could be, right?
Yeah.
And that kind of goes into like just making horrible assumptions.
Oh yeah, for sure. Because you can assume that a lot of parts of the code are error-free, and that's one of the reasons why unit tests are so important, is they'll tell you if they're error-free or not as far as the tests are written.
Yeah. And
you can quickly determine, hey, is this thing I'm depending on really doing what it's supposed to?
Yeah.
Like, for example, in a previous episode, we talked about singletons and how in a code base, we were told these are singletons, that's how they're operating. And so all of our debugging efforts were assuming that these singletons were working as expected.
Yeah. And
then it turned out, no, they're not actually singletons. You've got 4 or 5 of them at the same time.
Yeah.
And that assumption that they were working correctly and that was safe and error-free and we're going to ignore it.
Wasted a lot of
time.
And it costs a lot of money on small teams when you do that.
Yep.
Fixing a bug without reproducing the bug, big no-no.
Yes.
And a lot of developers, especially new ones, will jump in and assume they know where the bug is and try to fix it without replicating the steps.
Have you even tried running the program after you fix the bug? No, but
here's
push.
my PR. And then it doesn't compile. So you want to make sure you reproduce that, because you don't want to waste your time.
Yeah.
Because if you can't reproduce it, you probably should ask for more specific steps. You have to be clear on the problem.
Yeah.
And then you don't want to overcomplicate solutions.
You can't really fix something you can't reproduce.
Exactly.
Because you can never be sure if it's actually fixed.
Right. Exactly. Yep. And then the whole like clean code episode we just talked about, you don't want to overcomplicate your solutions with fixing a bug either. You want simpler solutions.
Just to recap, debugging is vastly important to your app. You're going to run into bugs no matter what, but it's a skill that's only going to improve over time and as you practice it. There's a lot that's involved. There's a lot of stuff with your environment. There's a lot of stuff with your skill set, with your understanding. So it can be hard to accept I'm crap at debugging, but it's something you can work on, and it's going to take time. And it'll be okay.
Yeah, and it's something that like it comes with practice and obviously continuous learning, but it's also something you can't really practice without experiencing it.
Yes.
Like it's like you can't fake bugs and practice troubleshooting and logging and debugging. You can, but you're not going to learn what you do.
You can watch as many martial arts movies as you want.
Exactly.
But you're not going to know how to fight unless you actually
until
fight.
You start doing it. Exactly. So don't like, if you're learning right now, debugging is a natural skill you're going to build.
Yeah.
But you can't be quick to quit and beg for help. Because you're learning how to debug when you run into problems.
Yeah.
Even if it's just IDE problems.
Mm-hmm. Which happen.
Which happen, yeah. So many people that are just like entering my Elixir Mentor channel, they're like won't understand how to set up their linter and things like that. And they're like, none of this stuff works. Well, like that's, it's part of debugging and growing the patience and know-how.
Have you tried doing it right?
Yeah. All you got to do is do it right, bro. But like, it's part of the learning curve though. Like learning how to use your tools properly is a huge part. Like, yeah, it's frustrating. You feel like you're wasting your time because you're not learning Elixir or whatever your new skill is, but you're still learning a lot.
Yeah.
Because you're learning how to use your tools.
For sure.
So hang in there, fellas.